Welcome to Tomorrow's World Today, a show dedicated to the discovery of innovation and cutting-edge technology. We showcase the latest developments from the greatest companies and smartest people in the world. Tomorrow's ideas are out there, and through our journey of inspiration, we will uncover the technology of the future. This is Inventionland World Headquarters. Here now is George Davison.
Tar and roofing shingles. Just seeing them brings a particular smell to mind. Most of us have lived in a house with some version of these materials as part of the roof and are familiar with this petroleum-based product. So how did these evolve into a high-tech product that protects manufacturing equipment? Lubricants are the secret sauce that keep the machines that manufacture products that we consume every day running smoothly and efficiently. In the past, various forms of oil and grease were used to reduce friction. Friction causes wear and tear on moving parts. With the world moving towards more sustainability and environmental products, I'd like to know how consumer lubricants are being innovated today. I've heard about a company named Hydrotex that pivoted from producing asphalt roofing to innovating high-tech lubricants. Rumor has it that they're using chemistry to improve and extend the lifetime of manufacturing machines and improve energy efficiency. I'm sending Darius to Dallas, Texas to look under the hood.
Manufacturing is one of the cornerstones of modern society and supports everyday life. Seeing that products are made on time and available to everyone is often taken for granted. How do we keep the machines that make our goods healthy and running instead of breaking down and ending up in landfills? You've probably heard the term like a well-oiled machine. Oil and grease were traditionally used, but as manufacturing equipment evolved, so did lubrication. Today, I'm exploring the world of high-tech lubricants and how this essential product has progressed to focus on sustainability, both for machines and for the environment. I'm here at Hydrotex headquarters in Dallas, Texas, to learn how they shifted from roofing products to developing some of the most cutting-edge lubricants used in manufacturing today. Hi, Eric.
Hi, Darius. Nice to meet you.
It's great to meet you. I'm really excited to learn your story and your history and how this company went from making roofing products to lubricants.
It's an interesting story I'd love to share with you. Hydrotex was founded in 1936 to provide protective coatings for roofing and construction. We very soon after that introduced a line of lubricants focused on the American farmer and rancher, small maintenance shop in rural areas where you had less access to information and goods than you do today. At the time, we had a simple product line. Lubrication science was much more rudimentary and basic.
It looks like you're also in the auto racing arena?
Where we were, and it was different than you might expect. We weren't in Formula One or NASCAR outside of this brief foray. We were in desert racing, giving Baja racers the tools they needed to compete in harsh environments. And that was really the image of our company. The 20th century Hydrotex was the American cowboy demonstrating through hands-on physical demonstration the benefits of our products. We were giving tools to farmers and ranchers to get a tough job done.
And now you're advancing and changing.
Well, yes, since that time, the American landscape's changed, and you have science and technology advancing now to give you the tools needed to achieve sustainability in the application. So that's when we've transformed into our current iteration, which is your lubrication solution partner. So we're not selling products anymore, now we're selling solutions for the application.
And what other industries are you in?
Well, we've expanded into many industries, including manufacturing, food processing, wind energy, and fleets and transportation, just to name a few.
Looks like you're also in technology.
While before it was a product-based sale, it's now a solution-based sale. So we're offering them not only the products, you also need to offer them the training at Lubrication University and lubricationuniversity.com or through on-site training and consultation. That's where these tools come into play. This is the demo kit for the modern salesman. We're using advanced metrology, power condition monitoring, vibration analysis, thermography, oil analysis, all of these tools to help the customer to prove sustainability and help them implement the condition-based monitoring program to be sustainable in the lubrication.
Well, I'm really interested in learning how this is made.
I'd love for you to see it, and I've arranged for a plant tour for you.
Oh, great. And then I'll come back and learn more at Lubrication University.
The professor's waiting.
Great. Hey, Scott, it's Darius. I'm here for my plant tour and to see how the grease is made.
Great. Welcome. Let's show you how it's done.
Great. So this is where the process begins, huh?
Absolutely. This is our stainless steel food grade manufacturing grease reactor. Process begins with our hydrosynthetic base oils that come in from above. And once in there, we have a PLC unit that controls a very specific temperature to create the reaction that we need to make a good grease.
Can I take a look inside?
Absolutely. Let's take a look.
So tell me what's been added in here.
So in here we get wax added, we get complexing agent added, we get anti-wear additives added, and tackifier.
And how long does this process take?
Probably takes about 2 days between cooking, milling, and testing.
Nice. How many barrels can you get out of it?
We can get 5 to 6 barrels out of this unit.
Wow, that's a lot. So can I check that out?
Absolutely, let's go look.
Well, that is definitely smooth.
Yeah. The grease is considered kosher and NSF 21469 certified.
That's because it's all food grade.
Absolutely.
Yeah, makes sense. Well, I've got so much more to learn about this, so I'm going to head back to Lube University and meet with the professor.
Perfect. I'll show you out.
Great.
So let's summarize the chemistry of lubrication.
I know I'm a bit late. Can I join class?
Sure, come on in. Well, we understand that if we're going to make a lube oil, we're going to use a base oil and additives of some proportion. And we know that additives have 3 functions: to protect the base oil, whatever it is, against oxidation, add or improve properties of that base oil, or add performance properties to protect the machinery. And we also talked about how we make grease, okay, the formulations of grease, where we have the base oil and the additives, but what makes grease so special and what makes it stay in place is metallic soaps or the inorganic thickeners that we choose. Are there any questions? Yes.
Professor, what makes your grease so special?
Come on up and I'll show you. So, the big difference between a grease and a liquid lubricant is they have different properties. So if we poured this liquid on the table, we would make a mess because it would run everywhere. But if we take a grease and we put it on the table, it's going to stay there a very long time. As a matter of fact, when we opened up the tomb of King Tut, he still had grease in his racing chariots, 2,000 years old.
Wow.
So synthetic greases, they'll last a very long time, and they will stay in place for a very long time. What else makes our grease so special is the fact that 20 years ago, grease manufacturing was called an art. And what we did, we took the art out and we put the science into it, controlling the heating processes, the cooling processes, the mixing processes. And also, what makes our grease so special is the guys I have in research and development that are coming up with these formulas.
Oh, great. Well, this is so performative. Thanks.
Well, thank you.
So I really learned a lot at Lube University and how your products are made, but now I'm interested in understanding product development and how you are creating customized solutions for your customers.
Every product solution starts with an idea, and that idea comes from working with our customers to solve problems. Take, for instance, this double spherical roller bearing that came from the main shaft of a wind turbine. The customer experienced a failure and asked us for a root failure analysis. If you look here, you'll see where high axial loading caused adhesive wear on the inner race. So much so that the grease has turned magnetic from the metal in the grease, from the wear. So this is a type of failure we often see in wind turbines. These are operating under extreme conditions that are leading to premature failures well below the design life for the wind turbines. And these are massive machines. They're way in the air. They're hard. They're expensive to service and maintain. Wind turbine operators need new tools to solve problems, to make this renewable energy source more cost competitive with traditional fossil fuel-based energies. We're working to give them those tools with our new projects to develop the highest performing greases yet.
So can you show me the customized solution you developed for them?
Yes, let's come into the lab. So Darius, now that we have our project plan in place to develop our high-performance grease for wind turbines, we'll step in the lab to conduct the experiments necessary to achieve our objectives. This is our lab-scale grease reactor where we're going to synthesize the candidates for evaluation. At its base, every lubricant starts with oil. This forms a thin film protecting the bearings from coming in contact, minimizing friction and wear. We've already combined these in here to achieve our target viscosity. Now, you'll often add additives, including extreme pressure, anti-wear additives. That's necessary in this case to prevent the type of failure we saw in that wind turbine bearing. Now, one step further, grease. Grease involves a thickener, which will hold the structure in place. It'll make it solid-like, allow it to stay in place where a fluid lubricant would fail. That gives it the structure and the ability to stay in place.
Ah, so is this the grease that's going to go in the bearing?
It is, yes. It was made in this reactor, and it'll now go on for testing in the lab. You want to come?
Yeah. All right, so can you tell me how you test the grease?
Okay, so a lot of our testing is done here in this test suite. An example is the 4-ball wear test. This is going to determine the extreme pressure properties and wear protection of our grease, which is what we need to protect the bearing in the application. We've already set up one experiment to show you. We have 3 stationary balls in a fixed position with our grease to protect them. We're going to load them under the top rotating ball before applying an extreme pressure to simulate the loads we're seeing in the wind turbine application. Gently, so that we don't harm the results of the test. Now we run it for 10 seconds. So that was a successful test. We've seen now that we can prevent wear and weld under those extreme conditions, which will give us an opportunity to protect the bearing in the application. If you think of product development as a funnel, you start at the top with endless possibilities of combinations. As we test and we refine and screen, we come out of the bottom with one final candidate compound. And this is what we'll then take in the pilot plant, and then we'll scale in our manufacturing plant for full scale to go on the field trials. We're about to start a field trial if you want to see how that goes.
Yeah. So tell me what you have set up here.
This is the start of a field trial that we're working on with the chemical manufacturer. They've got an electric motor driving a gearbox. The gearbox on it is really old. They want to see if they can improve the efficiency even further. They've adopted our synth gear oil. They want to go beyond that. They want to bring this gearbox into the 21st century.
And where would something like this be found?
Well, these are found all over the place, especially in industrial settings. This is an older unit, about 50 years old. That's the reality, is you don't replace it just because it's old. Condition-based monitoring shows this is still running great. The gears and bearings aren't worn, and the lubricant inside is in good condition, the synth gear oil. So we don't want to change it out, but we want to see, can we use this technology to enhance the energy efficiency and to increase the life expectancy.
And how do you conduct the field test?
Well, this is, we'll use things like vibration analysis to monitor the condition of the gears and the motors to make sure we're seeing that it's operating in a stable fashion. And then we'll use power monitoring to determine how much energy is being used to drive this gearbox to turn the agitator. And we'll have a thermal gun too. So if we're looking to look at energy efficiency, you're looking to reduce friction and wear. Temperature tells you a lot. Less friction, less wear, less temperature.
These are some of the things you showed me the other day.
It is, yes. This is the demonstration kit for the modern lubrication consultant. This is what they use in the field to help their customers with condition-based monitoring and to help prove sustainability in the application.
So what's in that top secret bottle?
Well, that's top secret. I can't tell you. It's the new nanotechnology that we're very interested in for driveline, for internal combustion engines. It's in my car now, and for gearboxes. So we're going to look at it here to see if it can improve the performance they're already achieving with Synth Rail to go further. The surface roughness of these gears and bearings is on the order of 500 nanometers. We're looking with this nanotechnology to smooth and polish those surfaces so that it's near 200 nanometers. Less surface roughness means less energy is lost through friction and wear. It'll increase the energy efficiency and the life of this gearbox.
And so it makes sense with how it works with, obviously, the machinery, but what about for sustainability and for the environment?
So with the Lubricants for a Healthier Planet initiative, we're working to bring clean energy, clean technology, and environmental stewardship to the world. With that in mind, we're purposely building every product. We're building the performance in to give the end user what they need in the application with the environmental friendliness and safety that the Lubricants for a Healthier Planet implies.
Well, let's take a closer look at it back in Dallas.
Okay, let's go. Darius, meet the other professor.
Oh,
This is our mobile training unit, which we take on the road to municipalities, school bus districts to work with their diesel technicians, help them understand how to use our engine oils, driveline products, and fuel improvers in their diesel applications.
so this is like a mobile classroom and the technicians go inside and learn.
Yeah, we open up the back, we file a class in there, and they learn the principles of lubrication, just like you did at LubU.
And what is this?
Well, this is an example of a diesel fuel storage tank. It's just a scaled down version that we use for demonstrations. So diesel fuel bulk users would have a much larger version of this. Theirs will be 10,000 gallons, but it's the same kind of idea here. They're going to fuel all of their mobile equipment, standby diesel generators with this diesel fuel tanks. We're treating with our fuel improvers, Power Clean year-round or Power Clean Arctic in the winter and northern climates. And this is going to help overcome the chemical deficiencies of the fuel and also to clean the injectors so that the engine runs at optimal efficiency.
So talk specifically about what companies or municipalities are using your products and how.
And this is a product that's in countless numbers of fleets, school buses, keeping children safe, helping them run even in the coldest weather.
So what does the future for lubricants and this company in particular look like?
We're continuing to focus on the 3 Ps: people, planet, and prosperity. But now the needs are changing. This is old technology. Diesels are the past. The future is electric, it's automated. So our next generation of greases are not only for wind turbines, it's going to be for electric vehicles, it's going to be for robotics. Our next generation of synth technology is going to take advantage of new chemistries that are now available. It's going to be bio-based, biodegradable. It's going to include ionic liquids and nanoparticles to achieve energy efficiencies we've never before seen. We're really looking forward and working towards a future where every lubricant is for a healthier planet.
Wow, this sounds so fascinating and I've learned so much. So thank you so much. I've got to head back to Pittsburgh.
Well, wait, before you go, we have a goodie box for George.
Oh my goodness, he loves goodie boxes, not to mention anything that is for a train, plane, or automobile or goes in it.
We have something in there for every application.
All right,
Thank you for coming.
You know, George, I started this journey curious about just how much you could actually do with grease. As engines and machinery get more complex, so should the internal fluids that lubricate and help them to run more efficiently. I never thought that with a bit of condition monitoring, you could improve the longevity and output of a 50-year-old motor and gearbox. But that is exactly what Hydrotex is doing in the middle of nowhere at a huge chemical manufacturing plant. It's hard to believe that they have come a long way since their days of producing roofing products. They've stepped up to take the challenge needed to create lubricants for tomorrow's up-and-coming vehicles and their motors. And they're starting with turbines and lubricating these huge bearings inside these massive windmills, hundreds of feet high in extreme conditions, delivering renewable energy across the country. This research has now been expanded to take into consideration new technologies dedicated to electric propulsion and futuristic vehicles, and even robots, while at the same time delivering a comprehensive solution-based approach to all industries that use lubrication. They gave me a box of goodies for you.
I got it.
And it's a top secret additive as well that may improve the output of your Demon. I hate to be the guy next to you when the light turns green.
Well, my supercharged Hemi's a V8 that's gonna love this. Well, tomorrow's ideas are upon us. Thanks, Darius.